In this video, I'm going to introduce you about the unions of two events. All right, unions of two events. So, what is meant by unions of two events? For example, I have events A and B, right? Events A and B. So events at A and B can be occur together. Sometimes it can be occur together. If they can occur together, we say they are non-mutually exclusive event. So means that there is an intersection between event A and event B, right? So means that there is an intersection between these two regions, between A and B, right? And this will is to be the A intersect B, right? The set of A intersecting B, right? So what is the additional addition rules or laws rules for unions of two events, right? For example, event A and B. So the formula here will be the probability of A union B for a non-mutually exclusive event will be the probability of A plus with the probability of B minus with probability of A intersecting B. Sometimes student asking me, why is it the A union B, the formula will be PA plus PB, and you need to minus subtract with a negative with a probability of A intersecting B. So a very simple explanation here will be, if I'm going to separate these two events, right, into two, right, I'm going to take it out. So it means that part of the events A is part of event B, right? This is called A intersecting B, right? Part of the event B is also part of the event A. Means that they are sharing the region with event A, and this region A is sharing with region B, right? So when we are going to taking PA union B, A union B means it's the overall, right? Means that A union B, this is the meaning of A union B, right? As you learned before during your set form 4 modern maths, right? The union means that everything here, right? So means that you taking the probability of A plus with probability of B, it will be a mistake for a non-mutually exclusive event, right? It will be a mistake. The mistake here is because when you add up these two, you try to think, if you take this and you overlap this thing is overlapped twice, right? Means you have added twice, right? When you take PA plus with PB, this region you have adding twice. Adding twice means they are twice. You calculate, right? So you have to minus an extra one here, right? When you minus the extra one here means that, let's say for this part here, right? For this part here, you have minus it, right? When you minus this, you've taken out one of the A intersecting B, right? You've taken out one of it, and you're going to join this together. You join this together, then you will form A union with B, right? A union with B. So you cannot take PA plus with PB, right? If you take PA plus with PB, means that you join them together. These two paper, for this is a paper, they will be overlapping, right? So they will double side. So means that I'm going to double layer, sorry, it's going to be double layer. This will be single, this will be double layer. So I need to minus away one of it, right? When I take PA plus PB, means that I'm going to minus one. Either you minus from here or from here. So when you join this, you were getting like a puzzle. You were getting something like this, right? It will be getting something like this. That's why the probability addition rule for the probability of A union B for a non-mutually exclusive event. What is meant by non-mutually exclusive? Means that the A intersecting B is not an empty set. It's not empty set. Means there is an intersection between the two events. Then we said that they follow this addition rules of union of probability, right? So this will be the formula for unions of two events. So all right, later on I will, in the same video, I will tell you what is meant by mutually exclusive. All right, let's talk about the unions of two events, which is a mutually exclusive event. For the just now I have talked about the non-mutually exclusive event. So now it's a two event. This is a mutually exclusive event. All right, I'm going to write here mutually exclusive event. Mutually exclusive events means that the two events cannot occur at the same time. For example, For example, you look at this diagram here. So the two events, they will not be overlapping between these two events. For example, the universal set, this is an event A and this is an event B. So these two events will not have an intersection, means that the elements, the set will be an empty set. The intersection between the two sets will be an empty set where there are no intersection between these two events here. Alright, so for example, A is the event of for example, a dice, right? An easier way will be a dice, right? Dice you have 1, 2, 3, 4, 5, 6, right? 6. A is the event that the dice giving a score of a prime number, odd number, right? 1, 3, and 5. And B is the event of the even number, right? Even number is like 2, 4, 6. Right? These two events is actually mutually exclusive. They are mutually exclusive. So for example, if let's say for this you have 7 and 7, 8, and 9, right? Maybe this is 1, 3, 5, 7, and this is 8, right? Here is 9, right? So if this is odd, this is even, right? So they are totally mutually exclusive. So there are no intersection between these two events here. Alright, so that's the how we explain mutually exclusive. So if this is a mutually exclusive event, I don't talk about exhaustive event in these cases here. Alright, so let's say if this is a mutually exclusive event, so the probability of A union with B will be the probability of A plus B, the probability of B. You don't need to go and minus with probability of A intersect B, as it will give you a 0. Means that the probability of A intersecting B for a mutually exclusive event will give you the value of 0. The probability is impossible to occur at the same time, right? That's the meaning here. So, right? Okay. So this is the addition rule for a mutually exclusive event. Means that the difference between mutually exclusive events and non-mutually exclusive event is that the difference is the minus P A intersect B, A intersecting B, right? So you have to go and search about what is the situation, right? The situations online, you can go and situation. There are many situations, all right, involving mutually exclusive events, right? Where an event occur, then at the same time it cannot occur at means that when you choose a number from here, it's either it's odd or even, right? It cannot happen together, or you get it's odd number and it's also even number. No, it won't happen, right? It won't happen. So for example, a situation that, for example, if you are a teacher, right? You are a sport teacher, then you have 10 students in your class, right? 10 students in your class. You tell your students that you have two types of game that you offer to them. It's badminton, okay? You can join either badminton or you can join hockey, right? Or you can join ping pong, right? Ping pong. So you have two games. So the school teacher said, the sport teacher said that you can choose either one of these or both, right? So there is a possibility it become a non-mutually exclusive event, right? Maybe there is how many students? For example, there are 7 students joining badminton, right? Joining badminton. So because you have set the rule, you tell them that you can join more than one game, right? So maybe 6 are joining ping pong, right? Ping pong. So when you take the probability of badminton, right? Probability of badminton, you're getting 7 over 10, right? You're getting 7 over 10. You take the number, divide by the 10, right? And the probability of joining ping pong is 6 out of 10. You're getting 3 over 5. Okay, 3 over 5. And this is, okay, let's say I use 6 over 10. So if I add up the two probability of badminton union with ping pong, right? Probability, either you take badminton or ping pong. So what is the probability? So you will get 7 over 10 plus with 6 over 10, which is very in logic, right? Not logic. 7 plus 6 is what? Is 13, right? 13 over 10, which is 1.3. How can a probability take the value of 1.3? Right? Probability cannot take the value of 1.3, which is probability is only happen for either is certain to occur or impossible to occur in between them, right? It's in between the value of 0 up to 1, right? Maximum you can include 1, you can include 0, right? But it's not 1.3. So something wrong, something happened here. Do you know why? Because these events of a student playing badminton and the events of a student playing ping pong are non-mutually exclusive. Means that maybe some of the students, right? Maybe some of the students are playing ping pong and also playing badminton, right? Means that there is a possibility that there is a overlapping here, right? Overlapping here. So the meaning, because you add up the probability, 7 plus 6 supposed to be 10, but now you add up, you get 13, right? 13 means that this is a non-mutually exclusive event. Non-mutually exclusive. There is an overlapping, right, between the two events. So how if the teacher said each student can choose only one game and you must play at one game, only one game? So it means that definitely if 6 take ping pong, 4 will take badminton, right? 4 will take, means they become a mutually exclusive event. It's become a mutually exclusive event because you can only take one game and you must play one game. So it means that you taking badminton, definitely you will not, a student that taking badminton will not take ping pong, right? They will not play ping pong because the teacher has set the rule, right? So this is called mutually exclusive event. This is non-mutually exclusive events. All right, that's the difference. That's why we need a knowledge for these two. If non-mutually exclusive, then you will have to minus with a P of A intersecting with B, right? And for mutually exclusive, then the A intersection B will be 0. So this is become the formula for that. So hope you understand.